Before we start this video, a large thank you to Johan, Zhu, Wei, Stefan, Lucas, AJ, Rumo, a name I unfortunately cannot pronounce. Thank you for support my friend, Jeff P, Adrian, and Corey for their support on Patreon. I hope you guys enjoy the video. And a tremendous thank you to Slim Shaggy on Patreon for their immense support to this channel and the series. You are greatly appreciated, my friend. Hello everybody. Gonna start this episode off by basically making some folders here to organize the scripts we made in the last video. Gonna really jump on top of organization immediately, so let's start by making a folder and call it scripts. I'm then gonna drag in all of the scripts that we made in the last video into this folder, and I'm gonna make some subfolders. So we want to separate everything from our player from everything else, like our regular characters or AI. So let's make a folder first called character, and we can drag the character manager in there. But then inside this character folder, let's make a player folder and then a player UI folder inside that player folder. Why am I doing this? Well, in the future, we're going to have a lot of scripts that will only have to do with the player's UI, and then a lot for the player itself. So it's best to keep them separated. So I'm going to drag the player UI manager into the player UI folder. I am then going to make another folder, and this folder will be for everything that is script related on the main menu scene. So in the future, we're going to have a lot more scripts here for stuff like buttons glowing, stuff for the character creation menu, all that stuff. So you can just call this menu scene or whatever you want, and then drag all of your scripts from the main menu in there. And then lastly, I'm going to make a folder just for the world managers scripts. In the future, this will have stuff like the world managers, item databases, action databases, all that good stuff. So now, when you're done that, load into your world scene, and let's make a small little room here because we're going to start with locomotion, and we need something to run around on. So I'm going to right-click and create a plane, and I'm going to go to scene view here now, and I'm going to use this texture I got from this asset that will be on the screen here now. I've edited the texture myself. Before I drag it in, I'm going to make a textures folder just to stay organized inside my art folder. And then I'm going to make a materials folder. So now I'm going to drag in my texture. I'm going to right click and create a material. And I'm going to assign this texture. Now I'm just going to make a simple little arena here to run around in. So if you want to skip that part, I will have a timestamp in the description, possibly on the screen. So you can skip that now if you don't want to watch that. It's just going to be a minute and a half or so of me constructing the arena. So I'm going to right click and create an empty game object in the plane, call it floor, drag it out, and I'm going to parent the plane under that. And I'm going to drag it down so it's in the bottom quarter of this empty game object. Okay, so it should be 5 in the X and 5 in the Z if you've done it right. I'm then going to duplicate it, drag one above it, and then duplicate 2 of them. So we have 4 planes now on this one floor game object, and the floor is in the dead center of the screen. Okay, that works well. I'm then going to create a cube, and I'm going to reset the transform so it's in the center of the scene. Then in the cube, I'm going to right click, create empty parents. I'm going to call this parent wall. So, fun fact about these cubes, if you didn't edit the size of the planes, 5 of these cubes is the length of a plane. So because of that, I'm just going to basically duplicate this until I have 2 on each side from the middle cube for a total of 5. Now, I don't like the way the material looks on them, so I'm just going to duplicate my material, call it prototype material 2, and I'm going to change the tiling of the material so it looks a little different than my floor. Now it looks like this. I like this more. So I'm going to duplicate these cubes 5 one time for a total of 10. And then I'm going to just keep duplicating these walls until I have enough to cover the entire arena. So each plane, as I said before, it's not 5 actually, it's 10, sorry. So if I duplicate them all, you'll end up with a result like this. I'm then going to create an empty game object. I'm going to call this construct. Going to reset the transform. Going to parent or create another empty under it rather called walls. And then parent all the walls under that wall empty game object. Now, I don't want to accidentally click this in the scene, so I'm going to tick this little icon here. Do you see this hand? Now, if I tick that on anything, you can see I can't click it in the scene, so I won't accidentally be opening up my inspector with all these walls, and I won't be annoyed. So you can tick that little hand on all of your construct, and now as you can see, I just can't click it. It's just a lot easier and neater for selecting other stuff in the scene. I'm then going to make it static because it's not moving. Next, I'm going to go to the player game object and drag him in here. Now, if you wanted to, you could start with obviously putting some components in the player right now. We're going to not do that, so just delete him. I'm going to save this scene and we're going to jump back to the main menu. And the first thing we're going to start with before we can actually start creating these inputs is we need a way to read inputs from our controller. So let's create an empty game object. I'm going to call it player input manager. All right, let's talk for a quick second about why I'm making this on a separate object. And again, you can do this however you want. There are dozens and dozens and dozens of ways to do this, but this is why I'm doing it. In short, when we start the network, our player object spawns in this scene. Now, if we go to the character creation menu in the future, we don't want to be able to control our player until we are in the world scene, because the player just needs to stand still while you select your class or navigate the menus, etc. So we only want the player to basically be able to be controlled when we're in the world scene. Furthermore, if we disable the player game object, we don't want to necessarily disable the inputs, which is why, again, it is on a separate object, because the player can be created or destroyed, and when you join a cooperative game, this player prefab will spawn in for another character, so it's best just to have it on its own separate game object in the scene and just have one of them. Okay, so you could also put it on the player UI manager game object too, but just for clarity's sake and giving it its own space, I'm going to put it on its own empty game object. So let's go here now and add a component, the player input manager, and let's click add and then open it up into Visual Studios. And as is per tradition, let's erase the start and update function and add our namespace. Okay, so I really want to instill the habit of writing out your goals one by one and doing things step by step in this series. So we're going to try to stick to that theme. So let's make some pseudocode here and say, think about goals in steps. So the first step obviously is we need to know how to read our joystick to move, or our input, our WASD key. So in order to move our character, we need to know the values of our joystick or keys. And then when we have that, we can move the character based on those values. So this is a pretty simple process. The first thing we need to do is figure out a way to read our inputs. So let's start with that. Now, we're going to use Unity's input system, which at the time of this video, I believe is at 1.4. Let's just see. So I'm going to go over here now into Unity Registry, click that, and then I'm going to search up here in the top right for the input, and then you'll see input system 1.4.4 at the time of this video. So let's install that. It's going to ask you to restart your project. Just say yes both times, and then I will wait for this to install, and I'll be right back. Okay, so now go to your event system, and if you see this little warning here, just click replace with input system. That just means basically we need to replace the old event system's inputs with the new Unity input system. So if you have any event system in one of your scenes, just hit that button. Now, what we want to do is right click, and I'm going to go to create here, and it's actually off my screen. So one sec, let me just fix my view here so you can see it, because it goes below the recording threshold. So I have the window open up here. I'm going to create, right click, and here you can see it is input actions. Let's create one of these. All right, so I'm going to call this player controls. I'm going to drag my project window back down here so it's fixed. I'm going to resize my windows. Okay, so let's open up player controls, and let's add a new action map. Think of an action map as just like a set of controls specifically for one thing. So I'm going to call this player movement because the only thing I'm going to put in here is my player movements controls. Now under actions, we start off with the default action. Let's just rename this to movement. Now it is not a button. It is a pass-through. That is the value you're going to want to use. Now under the control type, we also want to say a vector 2. Why is this? Well, think about it. We need two directions of operation, up and down and left and right on the joystick. So vector 2 just means we get two values of movement, again, up and down and left and right. So I want you to think of a vector 2 in terms of a joystick on a controller. Like I said, two directions. So we have the Y on the controller, that is joystick up, Y plus 1, or joystick down, Y minus 1. And then we have the X. Moving a stick to the right would make the X plus 1. Moving a stick to the left would make the X minus 1. The up and down is the Y position, and the left and right is the X position. Okay, so let's add an up, down, left, right composite under the movement action. So I'm going to name this left stick because I'm using this as if it were a left stick on a controller. I'm going to change the mode from digital normalized to analog. And the rest is pretty self-explanatory. You just fill in the up, down, left, and right values with whatever you want. So if you want a W key in the keyboard, you would put W keyboard on the up binding. But since I'm using a controller, I'm going to look for left stick / up on the gamepad. So that is the up direction on the left stick. Likewise, I'm going to do the same for the other respective directions. Down will be left stick / down. Left will be left stick / left. And right is left stick / right. So if you want to use any other controls here, go for it. It's all pretty straightforward. And with a little bit of tinker, you can kind of set up anything here. I'm only going to use the controller for now, and I'm not going to set up keyboard movements at this time. So when that's done, you want to close out and save. But now, how are we going to reference this from our script? If we go to our input manager now and try to type in player controls, as in the thing we just created in our game, you'll see that we kind of can't. So we need to figure out how do we read that from the player controls. If I type it up here right now, it just gives me an error and it doesn't recognize that it is anything in the project. What we need to do is go back to the player controls component here and generate a C# class and click apply. This basically makes it so you can reference these controls now from a script. So now you can see this turns into a variable. That's awesome. I'm going to call it player controls. So let's set this up so it will automatically create itself when we start the scene, or rather when this object comes online. Right below player controls, I'm going to start by creating an onEnable method. For those of you who don't know, this fires when the game object is active in the scene. So what we want to do is check and see if we have a player controls. If player controls equals null, let's create one. So let's create a copy of the control object we just made. We do that by just simply coming here and saying player controls equals new player controls. And that's it. So now, how do we reference our newly created joystick? Well, we need a vector2 to store the data that we're referencing, because as we said before, it's up and down, left and right. So we can just call this movement. And now we need to read the input from the joystick and assign it to that vector2 variable as we move our joystick. So we start by saying player controls, as in the player controls object we just created, dot player movement, as in the player movement action map, dot movement, as in the left joystick we just created, then dot performed, as in whenever this is performed, do something, plus equals I equals greater than movement. So what does this mean? Well, basically, when we move the joystick, we want to take the values and assign it to the movement variable. So then we say equals I dot read value vector2. And I'm just going to rename movement to movement input so it's super clear. So again, what we're doing is we're saying, hey, whenever we move our joystick, update the vector2 variable here to reflect the values of that joystick. So player controls, player movement, movement, whenever it's performed. So you can see here's the action map and here's the actions. This is what I'm referencing. Whenever this is performed, take the values from the performed action and give them to our vector2 movement input. And from there in the future now, we can use this in tandem with our player locomotion. So then we just come down here and we just simply say player controls.enable. And then we save that. And now we can actually go into the scene view and highlight our player input manager. And you can see here, since I made the movement input a serializable field, we can see it in the inspector over here. If I were to press play and I have my controller in my hand and I move the joystick, you'll see if I move it up or down, the Y value will change. And moving it left or right will make the X value change. Moving it a combination of the two obviously will make them both change. So if you move it up and to the right, the X and the Y changes, etc., etc. Okay, so that is working as intended. So what if you don't want the inputs to be active on the main menu when you're doing menu actions or creating your character? Because you don't want your character to walk off the screen in the character creation menu. So let's start by calling a library up here. We're going to say using Unity Engine.scene management. I'm using this because I want to toggle the inputs on or off when we switch scenes. So I'm going to make an awake function down here. And then I'm going to write inside the awake function scene manager dot active scene changed plus equals, and then hit tab twice and it will auto create a function for you. What does this do? Basically, when a scene changes, it runs this function. It is an event. So we have two arguments here, argument 0 and argument 1. I'm first going to rename the function to onSceneChanged, and then I'm going to make an onDestroy function out here, and I'm going to unsubscribe from this event in the event that this game object is destroyed. That just prevents memory leaks. So I'm going to make a comment here. When the scene changes, this function is running, basically, or it's ran once. What is argument 0 and argument 1? That is the old scene and the new scene. So I'm going to say down here, if we destroy this object, let's unsubscribe from the event. Again, that is to stop memory leaks and all stuff of that nature. So let's come in here and erase this. And inside, I'm going to rename argument 0 to old scene and rename argument 1 to new scene. And what we want to do is basically activate the input manager if the new scene is equal to the world scene and disable it, or do nothing if the new scene is equal to the menu scene. So I'm going to make a public static player input manager up here because there is only going to be one input manager in the scene at one time. I'm going to call it instance. And I'm going to set up my singleton like I've done before several times now in this series. So the order of operations here is very important, and I'm going to discuss that right now as I type it. So first you want to establish your singleton. If the instance is null, the instance is equal to this, else we want to destroy this game object. So that needs to come first, absolutely. So awake is obviously called before start, so that's why we run it on awake and not on start. Now on scene changed, we're going to say if the new scene scene.buildIndex is equal to, and remember, we had this somewhere before, didn't we? Let's go look for it. So we had this on our world save manager. We don't want to put a number here because if we ever change it from here, we want it to change everywhere. So it's best just to reference this variable. Now you can make it public if you want, but if you're afraid you're going to accidentally overwrite it, instead of making it public, what you can do is just make a function public and make a type of int and just call this get world scene index. And all you type in here is return the world scene index, and anything that calls for it just gets that variable from the script. Then we can say if new scene.buildIndex is equal to world save game manager.instance, our singleton, .get world scene index, then we know we are in the world scene. What do we want to do then? Well, we want to say instance, as in our input manager, this input manager, .enabled is equal to true. Now, this is not the game object being enabled. This is the script itself being enabled. So when this is enabled, any update functions on the script will run accordingly. All right, so otherwise, instance is equal to false, or instance enabled is equal to false. We are loading into our world scene and enabling our player inputs or player controls. And then if we load into any other scene, we're at a menu because this project is going to have the world scene and a menu scene, and then we want to disable them. Now, you don't have to do this. There's again, dozens of ways to do this. This is the way I landed on, and I like it a whole lot. So I'm gonna make another comment here. This is again, so when we make our character creation screen, or when we're navigating the menus in the future, the character in the scene view is not just running around, because if you use the joystick, for example, then the character will move around if you enable it. So that's why we have this set up here, like so. All right, so now that that is in its place, let's go back to talking about the order of operations. So right here, we're checking for the scene or subscribing to the event on awake. We also need to make sure we don't destroy the game object. So let's make a start function. And as we said before, we want to say instance.enabled is equal to false. We only want to turn it on when the scene changes. So let's go into our prefabs and world managers, or just where the player is, and create a prefab of our player input manager. So that's saved. And then on start, we want to say don't destroy on load and pass the game object. But now this won't work because we're basically turning off this game object before we call don't destroy. So what we need to do is make sure don't destroy is called before we turn off this game object. So place this scene active change and start after don't destroy. Now if you go into the game and you run it, you can see it works because it's under the don't destroy on load in the hierarchy, and the player input manager is not enabled. There's no checkbox. We load into the scene and there it goes. It is enabled. So that is working as intended. Excellent. So what's next? Well, we have a way for our inputs to be set up. We have our inputs loading in correctly and enabling when we enter the world. Now we need to start creating the functionality of our player to actually read these inputs and do actions accordingly. Now we have our character manager, and this is great, but we need to make a player manager because the player is going to do the same thing as the character manager, but with some added functionality. So we're going to make it derived from the character manager, so it shares its functions, but it's going to have its own separate from it as well. Likewise, we need to make a player locomotion manager because this is how the player is going to move around. So let's talk about the script structure that will be on our characters in the future. We're going to have things like the character animator manager, the character locomotion manager, the character combat manager. Now, we don't want to have to call a copy of each script on each of these components separately. What do I mean by that? Well, if you want to reference, say, the character animator from the combat manager, you don't want to have to write the character animator variable on the combat manager and then write it again on the locomotion manager and then write it again on another script. So we want to centralize all of these actions in one place. That way, each other component only has to go back to this one place. That is the importance of the character/player manager. It's basically going to hold every component that the character needs, and if another component needs to reference any of these, they get it through this script. Okay, let's go back into our project now and open up the player manager and the player locomotion manager scripts. Let's delete the start and update and drop in our namespace as is per tradition. And we're going to do a few things with these scripts. So over here on the player manager, just going to again erase the start and update and drop in my namespace. And I am then going to minimize this, and we're going to go into our character scripts, and we're going to make a character locomotion manager script. So we have a player locomotion manager and a character locomotion manager. And we have a player manager and a character manager. Again, This is because a lot of characters will share logic, but players will sometimes have their own logic. So again, drop your namespace in, delete the update and start functionality. And now let's go over to our player manager, or our character manager rather. And as you can see, we have a private void awake. Let's change this to protected virtual void awake. And then when we go to the player manager, we change it from a mono behavior to a character manager. This means it inherits everything on the previous script. Now we can call override awake, but leave base awake, and the base awake runs this logic on the character manager, but now we can do our own that only runs on the player manager. So basically, we get all the functionality that we want from our base class, but we can make functionality for just the player itself. This means if we do stuff like making fall checks, we can have one class that shares it, so everyone gets the same fall check, the same in-air check. So now let's erase the character manager component from our player, and let's add the player manager component. This is on the player prefab. And then let's add the player locomotion manager script on there as well. Now, over on the player manager, I'm going to make a variable for the player locomotion manager. I'm going to call that player locomotion manager. And on awake, I'm going to say player locomotion manager is equal to get component player locomotion manager. This is because it sits on the same game object as the player manager. If I were to go into the prefab view here now, I will show you. You can see player locomotion manager, player manager. Okay, so now that we have that done, let's go back into Visual Studio. Let's open up the player locomotion manager. Let's make a public void handle all movement. And let's make some pseudocode here. So what do you want to do? We're going to say like, you handle your grounded movement, you can handle the jumping action or the jumping movement if you want to call it that. We can handle our ground check / gravity, our applying force, our rotation. So you can kind of break these down into its smaller parts, which we are going to do. So let's not get too far ahead of ourselves though. So for now, I'm just going to basically leave handle grounded movements, and we'll just say handle aerial movement. And we're going to break these down into their smaller parts too in the next video, of course. So let's go to the player manager again. And what we want to do is go to the character manager now, its base class. And then under here, let's make a protected virtual update function. And update runs on every frame, as I'm sure a lot of you or all of you know watching this series. So protected virtual void update. And again, we are then going to go back into the player manager and override that update. And we're going to leave the base there. So in the future, if we add function to the character manager, the player manager will get it too. And then we're going to say player locomotion manager dot handle all movement. Now this is basically going to run this function every single frame. I'm just going to make a comment here that says handle all of our characters movement. And now I'm going to save that. And now that puts us in a place where in the next video, all we got to do is start using our new inputs and our new structure to basically set up some player movement. So if you guys made it this far, be sure to drop a like and leave a comment. It does actually genuinely help out the series so much, you have no idea. As always, a special thank you to our patrons. It's because of you guys I get to keep doing this, and I love doing this. I hope you guys are enjoying the series thus far. I am going into more lengthy explanations as I really want to make sure that people who are watching are grasping everything that I'm doing. And if you don't know what's happening, please stop, pause the video, and take some time to reflect on what is going on. The goal is to give you a project you can edit yourself, not to just copy what I'm writing and then not know what it does. It's okay to copy what I'm writing as long as you know what it does, so you can change it if you want to suit your own needs. Okay, everybody, I'm very excited to start the next episode, so I will see you there.